Hello everyone, welcome to all of you in my lecture today. So here in this lecture, I am going to start the mass transfer operation for the chemical engineering for the gate examination and bark examination, right? So already on my YouTube channel, already I put so many videos regarding preparation of gate chemical engineering for different subjects like chemical engineering, mass transfer, plant design economics and process dynamics and control, all these lecture, right? So I hope if you'll go through all these video, you will find something very that will be very beneficial for your gate examination point of view, right? So now here in this lecture, I'm going to start the mass transfer, right? So try to understand the concept of mass transfer. It's a very diverse field and having lots of concept is there that you need to understand in the mass transfer. So here in this lecture, I will be starting from the definition of mass transfer and we'll go through slowly by different unit operation, different process of the mass transfer, right? So when we try to define the mass transfer, how can we define the mass transfer? The mass transfer can be defined as the net movement of molecules from a higher concentration to a lower concentration, right? So you all know the definition of concentration. So basically, if you want to define the concentration in the normal terms, we can define number of moles per unit volume. That is the you will all have studied in class 12. That is the molarity. So there are different types of concentration is also there. That is molarity, parts per million, mass concentration, molar concentration, all. So here in this lecture, I will be starting from the definition of mass transfer. So the definition of mass transfer is I am writing here. So you can define the definition of mass transfer. That is the net moment of molecule in a mixture from the region of higher concentration to the lower concentration, right? So yeah, this is the definition of mass transfer. So it's the simplest definition that I have written over here. So this is the higher concentration to the lower concentration. The molecules will be moving from higher concentration to the lower concentration. So it's the basic definitions of the mass transfer. Now try to understand the driving force of the mass transfer, because you know that there must be a driving force for the transfer of molecule from higher to lower concentration. So here whenever we talk about the concentration, the driving force must be the concentration difference, right? So there may be some different driving force may be there for the mass transfer. Let's see what are all these driving force, right? So I'm writing here the driving force of the mass transfer. So the driving force for the mass transfer, you can categorize this into two form. First, here I am writing for the single phase driving force. For the if only one phase is existing, then the driving force for the mass transfer is concentration difference. Concentration difference. So this is the introductory lecture that some people may be knowing these things, so you can skip. But those who are not knowing all these steps about the mass transfer, you should see this video, right? And from this, you can make a base for the mass transfer, and after that, you can understand the thing. Now, when we talk about the multi-phase system, for multiple phase or multi-phase, you can talk. So the driving force for the mass transfer is chemical potential. Very important concept, that is chemical potential. You will be studying in the thermodynamics, right? So this is the basics things that you need to understand the driving force for the mass transfer, right? Now, what happens that I have told you about there is a concentration difference. One is driving force is concentration difference, and one is the driving force, right? So try to understand one thing here. I'm not going into the deep of all these concept, but I should let you know about what is the concentration, right? At least that is concentration term, right? So let's try to understand the concentration. How can you define the concentration? So basically, if you want to define the concentration in the layman's language, so you can define the concentration is first I am trying to define the concentration as a molar concentration, right? Or molarity. You all have studied in class 12. Molarity is number of moles of solute per unit volume, right? Second term you can include molality, that is denoted by small m, that is uh, so weight of solute in gram upon weight of solvent in kg, right? So this is basically two concentration term. Third, you can define as normality, right? It is denoted by n, that is equals to number of gram equivalent of solute and divided by volume of solution in liter, right? So volume of solution liter. So this is the term, basic terms of the concentration. Fourth, you can define as the mole fraction, right? It's very important whenever you will be solving a problem of absorption and distillation or some extraction. So you'll get in cut with this particular concept. So when we talk about mole fraction in liquid phase, mhm, in liquid phase, mole fraction xi, that is equals to Ci upon Ct. That is concentration of ith component upon this is total concentration, right? And next, I want to define that is mass concentration. Sometimes you'll see that is mass concentration term, right? So how can you define the mass concentration term? Let's try to understand. Uh, So that is equals to mass concentration of uh, it is denoted by rho I, right? So that is rho I, that is equals to mi upon v, just like the density kind of thing, right? It is a density kind of thing. So that is mi upon b. So these are the basic concept that you should know when you try to solve the concept of the mass transfer, right? So now already I discussed all the term regarding concentration, right? Now I am going to define the term molar average velocity. That's a very important term. So I will be denoted it as a V bar, right? So you can define V bar, that is equals to summation of Ci Vi upon summation of Ci, right? Where you can write Ci is molar concentration and Vi is velocity of molecules, right? So see, one thing is that in a mixture, what happens? You will see there are lots of number of molecules are there. So every molecules will be having some velocity, right? So you can talk it as V1, V2, V3. So if you want to calculate the molar average velocity V, that is equals to concentration is C1 V1 plus C2 V2 plus C3 V3 plus dot dot upon C1 plus C2 plus C3 plus dot dot, right? So this is the way that you can find the molar average velocity. So sometimes summation of Ci, that is called as the total concentration Ct, right? So that is equals to total concentration. I think up to this point, everything is clear that how can you define the molar average velocity. Now I'm going to define some different stuff regarding the diffusional velocity, right? I'm defining it as u. So how can you define the diffusional velocity? Try to understand. So it is defined as u, that is defined as vi minus v1. What is vi? This vi stuff is velocity of individual molecules and v bar is average velocity, right? So you can define that diffusional velocity, that is equals to velocity of individual molecules minus velocity average velocity, right? Now next very important stuff that I'm going to discuss here is that is the flux. So here you can define that flux is the property that get transferred per unit time per unit area. This is called as the flux. So flux may be of different kind, but here mostly in our mass transfer operation, we will be studying two kind of flux. That is one is molar flux and one is mass flux. So if you can recap the concept of class 11, 12 physics, there you would have studied the electric flux or magnetic flux, all these things. So the electric flux and magnetic flux you would have defined there. That is the, I mean, the flux line, the electric flux line passes through per unit area per unit time is called the electric flux, and the magnetic flux field line that is passing through per unit time per unit area is called the magnetic flux, right? So here we have defined the flux, that is property passing through per unit area per unit time is called the, here that is a molar flux or the mass flux, right? Because the molecules is getting transferred from one component to one system to another system, or one component to another component. That's why here you can define that as a molar flux or mass flux, right? Now, uh, we have to study two kinds of flux here. That is types of flux. First is convective flux, and second one is the diffusive flux. Convective flux and diffusive flux. So first I'm going to define as here is convective flux, right? So how can you define the convective flux? So I'm trying to let you understand. It is the quantity passing through per unit area, per unit time, carried by some reference velocity, right? Here you can write quantity passing through per unit area per unit time with respect to some reference velocity, right? Reference velocity, and that reference velocity you can call it as the here that reference velocity is call it as the average velocity, right? It's very important that you should know that when we define the convective flux, when the quantity passing through per unit area per unit time with respect to the reference velocity, and that reference velocity you will be taking as the average velocity, right? So in the problem, if it is given the average velocity and some if has been asked to calculate the convective flux, then you'll have to calculate the flux on the basis of that average velocity, and that average velocity is the reference velocity. Now coming to the next point, that is diffusive flux. All that concept, that is average velocity and molar average velocity, all that stuff I've been just described in the uh, earlier slide, right? So here I am going to define as the diffusive flux. So how can you define the diffusive flux? So you can define the quantity passing through per unit area per unit time due to diffusion or due to the concentration difference, right? So let's try to understand. Quantity passing through per unit area per unit time due to concentration difference or due to diffusion. So try to understand, these two things are completely different. Here the molecules will be transferring due to this convective flux. There will be a bulk motion of the molecules throughout the system. But in case of diffusive flux, there is no bulk motion. Molecules will be transferring due to the concentration difference, or just like what is happening here. Try to understand how I can explain these things. Now, uh, if it is a deodorant bottle, try to understand here. If if I will open the cap here, what happens? Here it is deodorant bottle, right? So if I open the cap, what will happen? Here concentration of deodorant is very high. Here concentration of deodorant is very less. Less concentration. Here more concentration. What will happen? It will be getting transferred to the air, right? You are not doing anything. Once you press the that cap here, it is getting transferred to the air from the bottle. So here this is called as the diffusive flux. Diffusive flux, why it is happening here? It's happening due to the concentration difference. Are you getting? It is happening due to the concentration difference, one thing. Now what are you doing here now? Here now you are placing some uh, fragrance item, right? Having some item having fragrance, right? And you are trying to blow the air from here, right? Here this is a fan. What happens? The fan will be blowing the air. So this fragrance, if you are standing here, right? Don't just the if you are standing here, right? So what will happen? Uh, you will find some smell over here, right? So it is transported due to this flow. This is flow. This transfer of molecules due to this bulk motion. Here there is a bulk motion, right? Here there is bulk motion. Why? Because the fan is generating a bulk motion of this, fragrant molecule, and it is reaching to your nose, and you are able to, smell that things. That's why here it will be called as the convective flux. So this flux is due to this particular velocity of the air. If there is a average velocity of this air is there, so what happens due to this particular average velocity, you will be able to smell that particular thing, right? So that's why here it is called as the convective flux, and here it is called as the diffusive flux. Why? Here there is a concentration difference, delta C. But here you are able to smell these things due to this particular velocity. That's why it is called as the convective flux, right? So I have tried my best to let you understand up to this concept. So the next thing is that whenever there is a mass transfer operation is there, so the whole term will come, and the whole term will get added, and it becomes the total flux. So you'll have to understand the total flux condition. Total flux, that is equals to convective flux plus diffusive flux, right? So here you need to understand these things. And the total flux definition is, you can define the total flux for a molecules, that is, I am defining it as Ni, that is equals to Ci into Vi. Ci is concentration and Vi is molar velocity, and here it is molar concentration and molar velocity, right? So I try to understand one thing. Uh, I told you that convective flux is due to the transfer of molecules or quantity passing through per unit area per unit time due to a reference velocity, and that reference velocity is called as the average velocity, that V average, right? And here I have defined that total flux is Ci into Vi, that Ci is molar concentration of the IS molecules, and Vi is the molar average molar velocity. So can I write that is total flux, that is Ci Vi, that is equals to Ci V average plus diffusive flux. So can I define diffusive flux, that is equals to Ci Vi minus Ci V bar, sorry, Ci V bar. So you can write Ci, you can take common, so you can write Vi minus V bar, right? Vi minus V bar. So this is our diffusive flux. So I hope I have tried my best to let you understand the concept regarding the molar velocity, different types of concentration term, and the driving force for the mass transfer operation, and the different types of flux. That is, I have discussed about the molar flux and mass flux, and after that I have discussed about the convective flux, diffusive flux, and total flux. And convective flux is due to the molar average velocity, right? And the derivation of all. So in the next subsequent lecture, I will be discussing about the concept of the diffusion, and we'll be driving some relation between the convective flux and diffusive flux for different conditions. Okay. So thank you, and I hope if you like the video, then please try to subscribe the channel as well. Okay, so it will motivate me to come up with the new video, and more interesting video for making your preparation very easy, right? So thank you and all the best.